Hello. So today I am continuing with standard 12. Okay, and I am continuing with the next topic, that is the phosphorus. So today in this class we will discuss about the phosphorus, their occurrence. Okay, and we will also see their type of an allotropes. Okay. So today we will start a new topic. I can make a heading, that is phosphorus. Okay, write down phosphorus. Clear? So if you see the phosphorus, first we will see their occurrence. So you know the phosphorus symbol is, its symbol you know everyone now, P. The atomic number is how much? Okay, so 15, no? 15, and their atomic mass is 15 and 31. So 15 and 31. Clear this part? Now we will see the occurrence. First we will see the occurrence that phosphorus is present in plants. Okay, it is present in animals. Yes or no? Clear? It is present in plants. It is also present in the animal cell. Clear? Then next, it is present in the 60% of teeth and bones. Teeth and bones in the form of calcium phosphate. Calcium phosphate. Yes or no? So it is present in the plant. You can write down. It is present in the animal cell. It is present in the bones, in our teeth, in the form of a what? Calcium phosphate. You can write down. It is also present in term eggs. It is present in eggs. It is present in milk, in the form of phospholipid. Phospholipid. Clear? It is also present in our DNA and RNA. It is present in DNA. It is present in RNA. Okay. Okay. So this is also present in the DNA molecule, RNA molecules. Clear this part? Then you can write down it is also present in, see, this phosphorus is highly reactive. Phosphorus is highly reactive, hence their minerals exist. Their mineral exist. Their important mineral is phosphorite. Their important mineral is phosphorite. This is very important because we are going to do it based on this. Okay. So the important mineral you can write down is phosphorite. Then you can write down fluoroapatite. Then you can write down hydroxyapatite. Clear? Means in short, in the form of an apatite. Apatite means phosphate. Phosphate means apatite. Okay. So these are the occurrence of a phosphorus. Phosphorus are occurring in the plant cell, animal cell. Okay. In our body also phosphorus is present. Clear? It is present in the 60% of teeth and bones in the form of a what? Calcium phosphate. So our teeth and bones are made up of a calcium phosphate. Calcium phosphate, you know guys, Ca3PO4 12. This is calcium phosphate. Okay. It is present in terms of eggs, milk. You know egg yolk. You know white, yellow. When you break the egg, in that egg you are getting the yellow color yolk. So in that yellow color yolk, most of the thing is phosphorus. But that phosphorus is in the form of a what? Phospholipid. Okay. So phospholipid. Clear? Next, it is also present in terms of our DNA and RNA. It is present. See, this phosphorus is highly reactive metal. Okay. Phosphorus active molecule is P4 to remember. Okay. So a phosphorus active molecule is a P4. So this phosphorus is highly reactive metal, due to which it does not exist in a elemental state in the earth crust. Instead, it exists in the form of a minerals. The important mineral is phosphorite. Why the important mineral? Just now we will do this. The next is fluoroapatite and hydroxyapatite. Clear this part? Next, we will see the isolation of phosphorus. Clear? So I hope you take a screenshot of this. Then we will go with the isolation of phosphorus. How we can isolate the phosphorus. Clear? See here now. So next topic, you can make a heading, that is, write down isolation of phosphorus. Okay. Isolation of phosphorus. Clear? So write down. The phosphorus, see how to do this. First you have to take the phosphorus, one mineral, this isolation of phosphorus is done from mineral phosphorite. Is done from mineral phosphorite. Clear? And phosphorite is nothing but calcium phosphate. Clear? Calcium phosphate is nothing but what? Your phosphorite. Clear? This is your phosphorite. Clear? Now this phosphorite should be first reacted with silica, SiO2. Should be first reacted with silica. At nearly temperature you can write down 1773 Kelvin temperature. Clear? During this temperature will form a calcium silicate, CaSiO3. Yes or no? During this will form a calcium silicate and phosphorus pentoxide, that is P4O10. Now this calcium silicate or this phosphorus pentoxide is reacted with a coke. Coke means carbon. And again it is heated. When you heat this, you will get a P4 plus carbon monoxide. And certain temperature you can make a heading. The temperature is nearly, this also nearly 1773 Kelvin temperature. Clear? So this is one isolation of phosphorus, and this phosphorus what you are getting, that is nothing but a white phosphorus. We will discuss what you mean by white phosphorus, red phosphorus and black phosphorus. So this is a simple isolation technique from the calcium phosphorite. Okay, calcium phosphate. So in exam the question can come that how to isolate the phosphorus. So isolation or the obtaining process of phosphorus is from what? Calcium phosphate, that is known as a phosphorite. This calcium phosphate is reacted with silica at nearly 1773 Kelvin temperature. During this process, you will obtain a calcium silicate and P4O10. This will be in the form of a slag. It will be when you do this reaction, this calcium silicate will be it is one form of a slag, and it will be floating. It is having a very less density, and it will be floating on the top, so it is easily removed. So remaining portion is P4O10. This P4O10 is reacted with carbon in the form of a coke. Okay, so the coke is nothing but what? Carbon, and that temperature is also nearly 1773 Kelvin temperature. So you will obtain the phosphorus and carbon monoxide. Here whatever phosphorus you are obtaining, so we have three types of phosphorus. What are they? We will discuss just now. First you write down this and make a note. Chalo, you write down one note that phosphorus is isolated. Write down, chalo. Phosphorus is isolated by heating phosphorite with a silica and a coke in an electric furnace at nearly 1773 Kelvin temperature. Phosphorus is obtained. Clear this part? Now see. So we will see in a detail bit about allotropes of phosphorus, and then we will see the properties. So see here, allotropes of phosphorus. Clear? So we have three types of allotrope of phosphorus. First is white or yellow, one and same. Okay, white or yellow phosphorus. Clear? Second, you can write down red phosphorus. And third, you can write down black phosphorus. Okay, so third you can write down black phosphorus. Clear? So there are three allotropes of a phosphorus, that is white phosphorus, or you can say yellow phosphorus. Why? See, here only I will discuss one point, so that I will not write down in the property for the white phosphorus. See, whenever a white phosphorus you are preparing, whenever it is a fresh, so when fresh phosphorus it is there, it will be white. but after some time, and if it starts to react with some other thing, it will turn into yellow. So after some time it turns into yellow. So we can say both the name, that is white or yellow phosphorus. So there are totally 3 allotropes of a phosphorus. One is white phosphorus, red phosphorus and black phosphorus. See here, this white phosphorus is highly reactive. This is highly reactive, very highly reactive, hence stored under water. Please remember this, under water. Clear? So white phosphorus is highly reactive, hence it is stored under water. This red phosphorus is less reactive than white, and black phosphorus is less reactive than red. Okay. So I will write down the series in the terms of reactivity. So reactivity series, if I write down, reactivity series I write down P4, P4, P4. This will be white, this will be red, and this will be black. Clear? So white phosphorus is more reactive than red and is more reactive than black. Clear this part? So white phosphorus is highly reactive, very reactive, hence it is stored under water. Now student, why this white phosphorus is highly reactive? This is a very important question in P block element 2. This I will discuss after this lecture. Okay. So this is also one important question. So white phosphorus or yellow, there are 3 types of allotropes of phosphorus. One is white phosphorus or yellow phosphorus, then red phosphorus or black phosphorus. Highly reactive phosphorus is white phosphorus. Due to this high reactive in nature, they are stored under water. Then less reactive is red phosphorus, and then less reactive is black phosphorus. So this is the series, that is white is more reactive than red, is more reactive than black. Now this red phosphorus is polymeric in nature. Please remember, this red phosphorus is polymeric in nature. Okay. I will show the structure. When I will do in detail, I will show the structure. And this black phosphorus is having metallic luster. Okay, this being a non-metal, phosphorus is a non-metal. Okay, but the one question will come in the exam. Being a non-metal, whose allotrope is having a metallic luster type? So black phosphorus, being a non-metal, is having a metallic luster. So this, whatever I am giving, no, this point are nothing but your key points. Okay. So white phosphorus is highly reactive, hence it is stored under kerosene. Red phosphorus is less reactive than white, and black phosphorus is less reactive than red. So I have written this series. This sometimes it may ask in the exam. So white is more reactive than red than black. Why? I will discuss when I will do the complete theory. Don't worry about it. Okay. So red phosphorus is a polymeric in nature. Why polymeric in nature? When I will do the structures, you will automatically understand. Okay. And black phosphorus is having a hexagonal ring structure, layered structure. This black phosphorus is having a hexagonal type of a layer structure like a graphite. Okay. So black phosphorus is having a hexagonal layer type of a structure. When you see in the Pradeep, you can see that the structures are given. Okay. Red, white, red and black. Okay. So from I will do everything I will do, don't worry. So black phosphorus is having a hexagonal type of a layer structure. Clear? And due to this layer structure, this black phosphorus is having a one very important property, and that property is they have possess, being a non-metal, they possess a metallic luster, means they will shine. Clear this part? So now we are going to the next topic, that is a property of white phosphorus. Clear this part? So first I will discuss this white phosphorus, then I will discuss red, then I will discuss black. Clear? So write down, make a heading, that property of white phosphorus. Write down. So these are the nothing but the properties of white phosphorus. You can see here that white phosphorus, first property you can see here, white phosphorus is obtained by industrial synthesis, means this white phosphorus you are generating, you are manufacturing in industries. Okay. And when the white phosphorus is generated or manufactured in industry, when it is a fresh, it is white. I told you just now that whenever it is freshly prepared in the industry, it will be white, but slowly as the time passes, it turns into yellow. Yes or no? Who turns into yellow? This white phosphorus. That's why this white phosphorus is also known as a yellow phosphorus. Clear this part? This white phosphorus is also known as a yellow phosphorus. So first point is that white phosphorus is obtained during the synthesis industry, means in industry it is synthesized. Okay. When it is freshly prepared, when the white phosphorus is freshly prepared, means at that time this white phosphorus will be extremely white, but as the time passes it will turn into pale yellow or yellow in the color, hence this white phosphorus is also known as a yellow phosphorus. Clear? So see, it is very soft and wax like nature. Okay, it is a very soft and wax like a nature, like a cream, you know. You are applying, in a monsoon region, you are applying cream like Borolene, that cream. When you take that cream, it will be like a waxy substance, like Vaseline, okay. So it is a soft and wax like a having garlic odor. So this white phosphorus is having which kind of a smell? Garlic smell, okay. So it is a soft wax like having a garlic odor. It is highly poisonous, okay, and glow in dark, okay. It is also, it glows in the dark. If you keep for example, if you see in the laboratory, sometimes phosphorus are kept. When you go to the college, you will come to know, okay. So that white phosphorus are stored under water because of their high reactivity, and when all the laboratory is closed, and when you see from the outside, if the laboratory is having a dark room, you can see that something is shining like glowing. So that glowing portion is nothing but what? White phosphorus, okay. So the second property is, it is a soft wax like a substance having a garlic odor. It is poisonous and it is glow in dark. It will glow in dark. It is insoluble in water. When it is insoluble in water, it will be soluble in a non-polar solvent like carbon disulfide. Okay, na? So it is a soft wax like a substance having a garlic odor, clear, poisonous, glow in dark, and it is insoluble in water. Any substance which is insoluble in water means water is a polar solvent. So any substance which is insoluble in polar, so they will be guaranteed soluble in non-polar. So here phosphorus is soluble in polar, it is insoluble in water, means it will be soluble in some other non-polar solvent like carbon disulfide, clear. Next, it has a low ignition temperature, means it will ignite at a very low temperature. Due to this reason, it is stored under water. So as soon as it comes out the water, so the room temperature is enough to ignite the phosphorus. The room temperature, no? See, suppose I am keeping under the water, so temperature is lowered under the water. As soon as I take out from the water, so that out from the water phosphorus will come in the room temperature. As soon as the room temperature comes, phosphorus, that room temperature is enough to ignite the white phosphorus. That's why the white phosphorus burn in the presence of air, okay. So to remember this, it has a low ignition temperature. Who has a low ignition temperature? This white phosphorus, hence stored under water. So it has a low ignition temperature, hence it explodes or it reacts with oxygen and burns. That's why it is stored under water. So first point is what? That white phosphorus is, whenever it is industrial synthesized, it is freshly prepared, it will be white in color, but after some time it will turn into yellow. Second point is, it is soft and wax like a substance. I told you, no, like a cream, like a Borolene, like a Vaseline, having a garlic odor, poisonous. It is a poisonous, okay, it is a poisonous, and glow in dark. Here from this poisonous, I will tell you one thing, okay, what happens during the World War II and 1, I will tell you. So garlic odor, poisonous, and glow in dark, it will glow in dark, okay. It is insoluble in water, means something it will be soluble, so water is a polar, so it will be soluble in a non-polar like carbon disulfide. Low ignition temperature, due to this reason it is stored under water, clear. Next, it spontaneously catches the fire. Just now I told you, no, it has a low ignition temperature, hence stored under water. If stored under water means it is okay, normal, but as soon as you take out from the water, so it will start to react with what? It will start to react with the atmospheric oxygen. So here it spontaneously, means of its own, okay. So it spontaneously catches the fire in the air, okay. So it spontaneously catches the fire in the air and burns with a greenish glow. It will burn with the what? Greenish glow, and this phenomenon itself is known as a phosphorescence. So this point is very important. Please mark a key point here, that it spontaneously catches the fire whenever it comes out from the water, or whenever it is coming under the atmosphere of oxygen, okay. So it spontaneously catches fire in air and burns with the greenish glow, okay, and it burns with what? Greenish glow. This phenomenon is known as a what? Phosphorescence. So this is the reaction, okay. So P4, this P4 is white, okay, and reacts with oxygen to form what? P4O6. Clear this part? So and this phenomenon is known as a phosphorescence. What do you mean by phosphorescence? Means whenever white phosphorus is taken out from the water, so whenever white phosphorus is taken out from the water, it spontaneously catches the fire in atmospheric oxygen, and whenever it catches the fire in atmospheric oxygen, it will burn with the greenish glow. This phenomenon, no, this phenomenon is known as a phosphorescence, clear. And this reaction would have happened in the air with the phosphorus. Next, see here now, phosphorus, it is white. When white phosphorus is heated 573 Kelvin, when white phosphorus is heated with 573 Kelvin, you will get a allotrope of a phosphorus which is red, and when you heat at 473, you will get a black phosphorus. So this key point is also very important, that whenever white phosphorus is heated at 573 red phosphorus, at 473 black phosphorus. You have to remember this part, clear. So I told you, there are three allotropes of sulfurs. white phosphorus, black phosphorus, white, red and black. So whenever white is more reactive, less reactive than red, then black. So I told you the series also. So whenever the white phosphorus heated at 573, remember this temperature many a time they have been asked in the 1 mark fill in the blanks or MCQ, that whenever white phosphorus is heated at 573 Kelvin, they will form a red allotrope of phosphorus, and if it is heated at 473 Kelvin, it will form a black allotrope of a phosphorus. Clear this part? Next is very important, that whenever phosphorus reacted with sulfur, it will form P4S3 compound, tetraphosphorus trisulfide, yes, tetraphosphorus trisulfide, that is P4S3, and this P4S3 compound is used in the matches. The matches are known as a strike anywhere matches. See, you know that in market also it is available magic matches. I don't know, somewhere I have seen, whenever you strike, whether you strike on a wood or whether you strike on a iron, whether you strike on your wall, it will starts to ignite, it will starts to burn. So that type of a matches we say as a strike anywhere matches. Okay. So whenever this also is very important, that when phosphorus is reacted with sulfur, then whenever the phosphorus with sulfur means who with sulfur? White phosphorus with sulfur. So whenever white phosphorus sulfur is reacted with sulfur, it will form one compound. That compound is P4S3, tetraphosphorus trisulfide. This tetraphosphorus trisulfide P4S3 is used to form or used to make strike anywhere matches. Clear this part? So these are the properties. Some more properties are there. First you copy out, then you go to the next part. Clear? Write down. Chalo. So now see here, another properties of white phosphorus. See, the white phosphorus spontaneously catches fire, again forming with chlorine, okay, and it will form a two series of a compound. First is phosphorus trichloride and another one is a phosphorus pentachloride. See here, so whenever phosphorus it reacted with chlorine, okay, so it catches the fire and forms two series of compound. Either they will form PCl3 or it will form P4 plus Cl2 and forms PCl5. It depends the amount of chlorine. Okay. Now see, when we will balance here. Here how many phosphorus? 4. So I will put here 4. 4 3 is 12. So I will put here 6. Again phosphorus is 4. 4 5 is 20. So 10. So now see here. Here phosphorus is 1 but chlorine are 6. Here also phosphorus is 1 but chlorine are 10. So when I give the excess amount of chlorine, I will get PCl5. When I get limited amount of chlorine, I will get PCl3. So first property is, this property is also very important, that whenever white phosphorus is made to react with chlorine, it will get burned and catches fire with chlorine and form two series of a compound. Either it will form phosphorus trichloride PCl3 or it will form phosphorus pentachloride PCl5. See, you can see the amount of chlorine. If excess amount of chlorine is there, it will form phosphorus pentachloride. If less amount is there, it will form phosphorus trichloride. So first property is clear here again. So white phosphorus will catch fire or will burn spontaneously in the chlorine atmosphere or with the chlorine and form two series of a compound, either phosphorus trichloride or phosphorus pentachloride. Clear? Next, on reaction with magnesium, it gives phosphide. On reaction with magnesium, it gives phosphide. So how? We will see this. See, I will take phosphorus and I will get magnesium. Clear? So what I will get? See, this phosphorus is 15. 15 means 285. 5 means P minus 3. So P will form minus 3 here and Mg will form here plus 2. So Mg plus 2 here Mg and phosphorus here 2 here 3. So what I will get? Mg3 P2. Mg3 P2. This is known as a magnesium phosphide. Magnesium phosphide. Clear? So I will get two compound, I will get here magnesium phosphide. So it is written now that on reaction with magnesium, who on reaction with magnesium? This white phosphorus. So white phosphorus on reaction with magnesium, it will give phosphide. You can see this reaction. Clear? Next property. See, this property gives that phosphorus will undergo disproportionation reaction. See this reaction. Here phosphorus atomic oxidation number will be 0. Okay. Here phosphine. If you calculate the oxidation number of phosphine, see here. So phosphine means P plus 3H equal to 0. So P plus 3 equal to 0. P equal to minus 3 because hydrogen is 1 here. So here P is minus 3. Okay. Next, NaH2PO2. So Na plus 2H plus P plus 2O equal to 0. Here Na is 1 and hydrogen is 1. So 2 ones are 1. 2 ones are 2. P. Oxygen is 2 minus 2. So 2 2s are minus 4 equal to 0. So 1 plus 2, 3 minus 4 minus 1. So P minus 1 equal to 0, which imply P equal to plus 1. So here P is plus 1. Now see here. Here phosphorus is 0. So 0 to minus 3 is what? Reduction. Clear? Here phosphorus is 0. So 0 to plus 1 means what? Increase means what? Oxidation. So this property means to tell that phosphorus will undergo a disproportionation reaction and forms two series of compound. One is PH3 and NH2PO2, sodium hypophosphite, okay, in the basic media. You write down this one key point. So write down this point. You write down as a note. Write down. First write down this reaction. Okay, write down this reaction. Write down. White phosphorus with aqueous alkali like NOH. White phosphorus with aqueous alkali like NOH. White phosphorus with aqueous alkali like NOH. On heating, it will show disproportionation reaction. It will show disproportionation reaction and forms two compound. Phosphine, 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 that is PH3, and sodium hypophosphite, clear? So this is a one reaction chemical property that phosphorus on reacting with an alkali, it will form a two series of compound, and this phosphorus will undergo in a basic media as a disproportionation reaction. And I shown here phosphorus is 0, but in PH3 P is minus 3. So oxidation number decrease means reduction. So here phosphorus is 0 and here in NaH2PO2 phosphorus is plus 1. So here number is increasing means oxidation. Means phosphorus is only undergoing oxidation and this same phosphorus is also undergoing reduction. Means a single compound whenever will undergo oxidation and reduction means this type of a redox reaction is known as a disproportionation reaction. So this phosphorus can act as an oxidizing agent as well as reducing agent in this reaction. Clear this part? Clear this reaction? Now next. See, it acts as a strong reducing agent. Who? Phosphorus can also act as a strong reducing agent. It reduces to HNO3 to NO2, H2SO4 to SO2. See this reaction. See, here phosphorus is 0. Here phosphorus is 0 and here Cu is plus 2. Okay. SO4 minus 2 means here plus 6S and S is minus 2 here. Cu here 0. Here plus 1. S is here plus 6. O is minus 2. In H3PO4 if you calculate, so 3H plus P plus 4O equal to 0. Hydrogen means 1. So 3 ones are 3 plus P, 4 to minus 2 is minus 8 here. So equal to 0. So P will be equal to 5. So here P is plus 5. Clear this part? So here phosphorus is 0. But here in H3PO4 phosphorus is plus 5. So 0 to 5 is oxidation. So here phosphorus is doing oxidation means phosphorus is acting as a reducing agent. Yes or no? See, here phosphorus is 0 but here phosphorus in H3PO4 is plus 5. So 0 to plus 5 means increasing, means here phosphorus is doing oxidation and forming what? H3PO4. Any substance one which does oxidation is acting as a reducing agent. So this is an example of an phosphorus which act as a reducing agent. So to remember here that it acts as a strong reducing agent. Who? This phosphorus act as a strong reducing agent and reduces HNO3 to NO2, H2SO4 to SO2. An example have been given for the phosphorus with copper sulfate. If you see in your Pradeep, there is one more example they have given for the silver nitrate. Clear? Clear this part? So these are the examples of the phosphorus which act as a reducing agent. You can remember this, any one of the reaction it is enough, but this point is very important that it reduces HNO3 to NO2. Why? See, in HNO3 if you calculate nitrogen oxidation state, it will be plus 5. Yes or no? And here plus 4. So plus 5 to plus 4 reduce. Who will reduce? This P4. So P4 is acting as a strong reducing agent, but in this reaction P4 can act as a reducing agent as well as oxidizing agent because it is showing disproportionation reaction. Clear this part? Clear? Now see, one more point I like to tell. So here the chemical properties are over. First to take a screenshot. Taken? Okay. Now one more thing I like to tell here, and the thing is, see, during the World War II or World War I or World War II, I don't remember exactly, There were, if you see at your home, some radium things were available. There were people who were working with white phosphorus. Okay, so in ancient time, what happened in ancient time? People used to work with white phosphorus. At that time, they were not knowing that this white phosphorus is highly poisonous. Okay, so in ancient time, the people were used to used to work with the white phosphorus without any precaution. They were used to work simply as it is. So they developed one disease, and the disease name was Phosphorus. They developed one disease, and the disease name was Phosphorus. Phosphorus means here you are having this jaw. This jaw bone is slowly start to deteriorating, and it becomes very soft, and finally your mouth becomes open. Okay, so that type of a disease is known as a Phosphorus. Phosphorus is nothing but our jaw bones. This is known as a jaw bones. Okay, so these jaw bones starts to deteriorate or starts to become soft. One point will come, your mouth remains only open. So you can see when you search in your Google and you see Phosphorus jaw, and you see the people, the ladies are wearing a handkerchief to keep their mouth closed, because their people, that type of a people are developing a disease, and the disease known as what? Phosphorus. So remember that people working with the white phosphorus, if you are working white phosphorus with a bare hand, you will develop a disease, and that disease is known as a Phosphorus. You can write down here, this point is important. You can write down that person working with white phosphorus, which develop a disease, person working with white phosphorus will develop a disease known as a Phosphorus, in which the jaw bones will decay and become soft. The jaw bones becomes decay and become soft. Okay, so you can search on Google, you will see certain images on the Phosphorus jaw people. The Phosphorus jaw, you can, when you go and search the image, you will see the people are taking the handkerchief and tying handkerchief on their head so that their mouth remains closed. If they do not do that, their mouth automatically remains always open, because this jaw bone is soft and becomes decayed, so this will not help to close the mouth. Okay, so this type of a disease, Phosphorus jaw type of a disease, is developed by a white phosphorus. Clear? So you can remember one thing, this is not a very important key point, but you can remember that as you know this white phosphorus, I told you in the previous section, I will tell you one point, that what will happen if it is a poisonous. So this kind of disease will develop. That's why people working with the white phosphorus will develop a disease known as a Phosphorus jaw. Clear this part? So I hope you have understood. If you have any doubt, you can ask me directly. And there is one more important topic based on this white phosphorus. There is a structure of white phosphorus, and why white phosphorus is highly reactive. We will understand with the structure in the next class. Clear? Thank you.